Functions. Write that down there. We'll kind of define it. It's kind of a hard thing to define. A function, really for right now, probably will just get by with saying, oh no. Where'd it go? That's a bad and honest sign, can I tell you? Vimeo Studios. Vimeo Tools. Is it coming? Somebody say yes? Give it time. Every now and then it's just a little slow. Wait, can I still write? All right. Here's an example of a function. A function is like a formula. If you wanted to find the, let's say you've got a square. Did we do formulas of squares? We did, didn't we? Did we write down all these formulas? Okay, where the area of a square, oh wait. No, let's not do area. Let's do perimeter of a square. How do you find the perimeter of a square? Brian?
Add all sides together.
And how would I show that? Rather than, we didn't do it, although this would be it. This is not what we did. We did perimeter as what? Not side plus side plus side plus side, which it is, but the easier way to say that, easier way to do it here is 4s. Yes, that is, this is our rule, but this is what we call a function. And a good way to think about it like that is this, okay? If we have a table here, and this is my s, and this is my p, a function is like a machine, okay, where you put in this first number, the input number. In this case, the input number is how big the side is. You put it into this little machine here. It performs some sort of action on it. In this case, it takes it and multiplies it by 4. And then it spits out an output number. So like, for example, let's say a side is 3. You would put 3 into your little machine. The little machine multiplies by 4, and out comes a 12. The perimeter would be 12. If a side was 5, you put it in the machine and multiply it by 4, and you would get 20. And that's really, for right now, all you need to do to think about as far as a function. Inputs and outputs. So they're going to ask you something like this. So don't get confused by the word. You could substitute the word rule in for function, but apparently we have to use function. Let's say you've got L and M. L and M. And you have these inputs and these outputs. 520. 520. 1025. And 1530. And then there's a 7 here, and they want you to find this first. But what function could I write, or what rule? And the question is this: what do you do to the letter L to get the letter M that works for it every time? So you're going to say M equals, you're going to do something with L every time. Now you might think looking at this first one that you just multiply by 4, right? Because 4 times 5, but does that work for this? No, so we have to change our ways. What else could you possibly do here to get from this to this? Don't always think multiplication. Maybe we should think, Maggie.
Addition.
And what are we adding?
15.
15. So the function would be M equals L plus 15. And what would be the answer for 7 if you put 7 into this for L? 7 plus 15 is 22. kind of get that? It's really nothing more than a formula. Another way they might do it is like this. Sometimes they turn the tables on the sides. And they say, okay, here is x, and the bottom is 2x plus 2. 2x minus 2, 2x plus 2, 2x minus 2. And then you're given a bunch of numbers and you have to plug them in to see what happens. If my x was a 2, and I input that in here, what would I get for this part, this down over here? 2 times 2 is,
4,
minus 2 is,
2,
what if my x number was a 6? 2 times 6 is,
6,
12 minus 2 is,
10,
what if my x was 10? 2 times 10 is,
20,
20 minus 2 is,
18.
18. And that would be my little ruly bobber thing there. And then they talk about, oh, well, let's do this one. Then they talk about graphing functions. Have we graphed things before? On a number line?
Yeah.
Well, maybe not. Here is your table. Yeah, it looks like this: 1, 2, 3, 4, 3, 6, 9, 12. X, Y, 1, 2, 3, 4, 3, 6, 9, 12. Have we graphed lines? Yes, no? We did last year? If you were asked to graph this, how do we go about doing that? I don't remember if you guys have done this or not. We graph this on a rectangular coordinate system. Yeah, we done this. Yeah. Where these are your coordinates, in other words, x is 1, y is 3, that's the same thing as 1, 3 in parentheses. 2, 6 is the same as 2, 6 in parentheses. This is the same thing as 3, 9 in parentheses, and this is the same thing as 4, 12 in parentheses. So when you graph it, it would look like this. The point 1, 3, 1 over 3 up would be there. 2, 6 would be a point up here. 3, 9 would be, you would have this on a nice piece of graph paper. But for this, when you graph this, okay, all of these points will fall in a nice line, mind you, because I'm not a very good grapher here. And you would have to connect those dots all with a nice straight line. Have we done that? No, yes?
No.
I don't know if yes and no. No? Yes?
No.
All collectively? Oh, that was everybody? It's a little disappointing. All collectively?
No.
Let me see if there's a problem here. I don't even see one where they tell us to graph it. Then graph the ordered pairs on a coordinate plane and extend the radius of the points to represent the function of the equilateral triangle. Blah, 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 blah. Well, let's just do one more. Maybe this will make some sense to you. Let's say you got a job. Let's say Noah got a job. Noah's not really old enough to work, so how much are you going to make an hour? It's got to be less than minimum wage. You're just not old enough. Whoa, he works for relatively cheap. Noah just wants to, let's go a little higher. Let's go $3. I'm going to give Noah $3 an hour. Okay, so here's the whole deal with graphing there. All right. First of all, what would be the function we could write with that? What function, what rule would we do there? We've got money, we've got dollars, and we've got hours. What rule would you get there? So the amount of dollars Noah gets is equal to what? What would be the rule? How many dollars is he going to get? David? 3. For how much? Every hour he works. So here's my function, my rule. Okay, if I were making a table of this, it would look like this to figure out how many dollars. This is my input number because how many hours is he going to work? If Noah doesn't feel like working and he works 0 hours, how much money is he going to make? $0. If he works for 1 hour, he's going to make $3. If he works for 3 hours, he's going to make
$9.
$9. If he works for whatever. Now let's stop there. Now let's graph these points. See if you can make this connection here. If I take my coordinate system and I make this line right here my number of hours, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And the up line is how much money he makes, dollars, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we graph these points. Here at 0, 0, he worked 0 hours, he gets $0. He worked 1 hour, he makes $3. He worked 3 hours, 1, 2, 3, he gets 1, 2, 3, 4, 5, 6, 7, 8. He gets $9. Okay? Now, connect to those dots, and what does that line stand for? I'll move my dot over there. This line stands for all the combinations of hours and dollars he would get. In other words, here at 2 hours, guess where 2 hours crosses this line right here at 6. But what if he only worked an hour, or 2.5, or an hour and a half? Well, if he worked an hour and a half, here's right halfway between an hour and a half, it would come straight up here and get right there. Even though it doesn't fall on the line there, it's between what, $4 and $5, he would make $4.50. This line goes on forever, and it would stand for no matter how many hours he worked, you could always figure out how much money he made just by following that line. So if you were way out here at 7, guess where 7 would cross up here? At 21. So 7 hours is $21. 5 hours is 15. This line is the answer to every possible combination you could get, because it would go on forever, that's what this line. But that's what this line stands for. It's all the answers. Because, you know, if I asked you how much money Noah makes, if I didn't tell you how long he worked, could you give me an answer? No, but the line would be the answer, because that line gives all the answers. Yeah, I wish that would have gone over better too. It was good.